4 distributions built for classrooms and 3 of them are dead. One discontinued in 2017 with security vulnerabilities unpatched for nearly a decade. Another emerged from a $100 laptop initiative for developing countries that peaked before most of its intended users had reliable electricity. The third targeted children as young as 3, with an interface so simplified that its current status cannot be confirmed from any official source. Only one remains active, backed by the same organization, maintaining one of the largest distributions in existence. The question this comparison answers is not which educational distribution to install. It is why an entire category collapsed while the problems they solved still exist, and what the sole survivor reveals about keeping a specialized distribution alive when cloud platforms and cheap hardware rewrote the rules of classroom technology. Edubuntu launched as the official educational variant of one of the most widely deployed distributions on the planet, inheriting the same update schedule, the same repositories, and the same long-term support guarantees that enterprise deployments depend on. The software collection spans mathematics, science, geography, astronomy, chemistry, and language learning across bundles organized by education level from preschool through to tertiary. Over 100 interactive activities ship pre-installed for younger learners. A virtual globe teaches geography, a desktop planetarium teaches astronomy, algebra, fractions, geometry, and calculus each have dedicated applications. The network deployment capability separates it from everything else in this comparison. A single server installation can supply an entire computer laboratory through thin clients, meaning old hardware that cannot run a modern operating system independently boots from the network and shares the server's resources instead. Centralized management means software updates, user accounts, and content filtering happen once rather than on every machine individually. But the same comprehensiveness that makes it valuable for institutions creates its tension for individual users. The download exceeds 3 gigabytes. The desktop environment demands more resources than lightweight alternatives. The application library is extensive enough that finding specific software requires navigating broad categories rather than intuitive menus. For schools where official backing, long-term support guarantees, and network deployment across an entire laboratory from a single server represent exactly what classroom infrastructure requires, accepting that the comprehensiveness making it suitable for institutions is the same comprehensiveness overwhelming individual learners who only need a fraction of what ships pre-installed. UberStudent targeted an audience the others ignored entirely: university students, researchers, anyone whose daily workflow revolved around reading academic papers, managing citations, writing essays, and organizing study materials. The reference manager that shipped pre-installed became one of the most widely used academic tools in existence, now available on every major operating system. The spaced repetition flashcard system followed the same trajectory. Both applications outgrew the distribution that popularized them. The lightweight desktop environment ran comfortably on older hardware. Reviewers consistently noted the menu organization was superior to every competing educational distribution, with applications categorized by academic function rather than software type. The text and writing emphasis reflected what university students actually needed rather than what educational software collections traditionally provided. But the project depended on a small team without institutional backing, and in 2017, development stopped permanently. The underlying base has not received security patches in nearly a decade. The software versions frozen at that moment contain vulnerabilities discovered and fixed everywhere else years ago. What UberStudent demonstrated before it died is that the academic workflow it identified was real, the tools it selected were correct, and the approach of curating existing software for a specific audience had genuine value. The distribution failed not because the concept was wrong, but because maintaining an operating system requires sustained resources that a small independent team could not provide indefinitely. Every tool it championed now installs in minutes on any modern distribution. Sugar on a Stick emerged from one of the most ambitious technology education projects ever attempted. The One Laptop Per Child initiative aimed to put a $100 laptop in the hands of every child in the developing world, with a custom learning environment designed from scratch around a philosophy that children learn by doing rather than by being told. The interface abandoned every convention of traditional desktop computing. Applications were called activities. File management was replaced by a journal that recorded everything chronologically. A neighborhood view showed nearby users available for collaboration. The entire environment fit on a standard memory stick, booting from any compatible machine without installation. The philosophy was constructionist education translated directly into software design, programming taught through visual block-based tools rather than text. Collaboration built into the environment at every level rather than added as an afterthought. The mesh, networking allowed devices to communicate without infrastructure, designed for classrooms where reliable internet did not exist, but the initiative that created it peaked between 2007 and 2012, then faded as the $100 laptop proved more difficult to sustain than to announce. The interface that made it accessible to children made it incomprehensible to teachers trained on traditional desktops. The skills children developed inside the environment did not transfer to the conventional computing interfaces they would encounter everywhere else. Development has slowed substantially. The community that remains is smaller than what the ambition of the original project promised. For understanding what happens when educational software design prioritizes pedagogy over convention, Sugar demonstrates both the potential and the cost of building something that refuses to look like anything else. Qimo targeted the youngest users, children from 3 years old, with large icons, bright colors, and a simplified interface designed to reduce the intimidation of a machine that most adults find complex. Educational games taught mathematics, typing, drawing, and pattern recognition through play. Parental controls restricted access to age-inappropriate content. The design philosophy assumed the user could not read and might be encountering a computer for the first time. The target audience was simultaneously the project's purpose and its limitation. Children aged 3 to 8 represent roughly 5 years of relevance per user before they outgrow the environment entirely. The software collection focused on games rather than full curriculum coverage. As of 2026, the project's status cannot be confirmed from official sources. The website is difficult to locate. Recent development activity is not visible. The underlying base, if unchanged, contains the same security vulnerabilities that affect every unmaintained distribution built years ago. What Qimo represented was the narrowest possible audience for an operating system, and the question it leaves behind is whether an age range of 5 years can sustain the volunteer effort required to maintain an entire distribution when every application it shipped is now available as a package on any actively maintained alternative. Edubuntu for schools where official backing, long-term support, and network deployment across a laboratory from a single server represent what classroom infrastructure requires, accepting that the comprehensiveness making it suitable for institutions overwhelms individual learners who need a fraction of what ships. UberStudent as a historical reference, proving that the academic workflow it identified was real and the tools it selected were correct, accepting that maintaining a distribution requires sustained resources a small team could not provide, and that every tool it championed now installs in minutes elsewhere. Sugar on a stick. As a demonstration of what happens when educational design prioritizes pedagogy over convention, accepting that the initiative creating it faded and the unconventional interface that made it accessible to children made it incomprehensible to everyone responsible for deploying it. Qimo as the narrowest audience an operating system ever targeted, accepting that 5 years of relevance per user could not sustain the volunteer effort required to maintain an entire distribution. One survivor. 3 lessons in why specialized distributions die when the software they curate becomes available everywhere. Every choice is a trade-off. At least now you know what you're trading.